Okay, so in this segment, we're going to talk about the distributive property. This is a very important part of algebra or in basic mathematics because this tells us how we can take something and distribute or uh, share with some other groups of people or individuals or objects. So the distributive property is the general idea of this is that you are taking something and giving it to everyone in that group. That's really the fine general idea of it. Just to kind of make it very simple and non-mathematical for now. So, for example, if you take something like this, let's say you have five. I know. Let's say you had $5 and you have a group of people. Let's say you have A, you have a B, you have a C, and you want to take that $5 and say that you're being very generous, like you're going out to dinner and you're going to leave $5. Well, technically, if everybody puts $5 in, that's $15. But really, how you're going to kind of look at this way is you're going to say, okay, well, this is going to be equal to, well, that means this $5 goes to this A. So we have 5A. This $5 also goes to this B. So that's going to be plus 5B. And you're going to say this $5 goes to this C. So that's plus 5C. So you have this that comes out of this fact. So this 5 is going to come to A. This 5 is going to come to B. This 5 is also going to go to C. So this is what we call the distributive property. You're giving 5 to everything in that parentheses. And that's pretty much it. I mean, that doesn't do too much to this. Okay, so to kind of get this kind of completed, we need to really do many of examples. I mean, that's kind of what our process is here. So let's do some examples here. So examples. Okay, so let's do number one. Let's just do something like this. What about 4 times 1 plus 4x? So something like that. So you're probably thinking, okay, well, if going from this to this, you're gonna pretty much do the same part. So, so you're gonna take the 4 and boom, go to that. And then you're going to take the 4 and go to that. And I'm hoping that you're seeing that the plus separates this. So the plus right here, this is really a separation of the two. So this should come out to 4 times 1 plus 4 times 4x. So really it's a multiplication part. So this is 4 times 1 and this is 4 times 4, but the x, remember the x needs to follow. So you have to be very careful. This does not mean times, this means a variable. So this right here is what we call a variable. And a variable is just something that's itself. So now I don't want you to leave it this way. I want us to actually go to further. So 4 times 1, I hope 4, and then plus, and then I hope that we can do 4 times 4, which is 16, but the x comes with it. So that should be your answer when the 4 distributes to all the other two components of this. So hopefully that wasn't too bad. But like I said, we need to do more of these and see a variety of them. So let's do another one here. So maybe number 2. And let's do negative 6 times x plus 4. Okay. So something like this is, you can almost see the similarities between these two. See, a lot of this is just repetition. And so that's pretty much all you got to do is just kind of keep that repetition down in the problems. So again, we're going to go boom, and we're going to go boom. Okay, and this is going to equal, well, what's negative 6 times x? So this is negative 6 times, we can put 1x. And I hope that you understand that x right here and this x are the same. Because how many x's technically you have right here? You have 1x. 1x. How many you have here? You have 1x. So I want you to make a little note. A little note right here. If you see an x, that equals to 1x. Okay, that's a little note right there. So now keep going. What's negative 6 times 4? Well, negative 6 times 4, 6 times 4 is 24. But there's a minus with it. There's a minus with it. So this is going to be minus 24. Now, I don't want you to leave it this way. So this really resorts down to almost PEMDAS again. This resorts down to PEMDAS. So you're really going to use your PEMDAS on this one. And you can see it. So we have negative 6 times 1x, which is negative 6x. And then bring down the minus 24. And there you go. Okay. So some more examples. So try this one. Negative 6p plus 7 times negative 4. Now, in this one, I hope that you can kind of see that these are pretty much just in reverse. These are just swapped. And that's okay. You're going to do the same thing with this one like you did here. But you just see how these are just swapped? So these are just swapped. I mean, I guess you could write it in this fashion, but really let's keep it, the same way. And I know that some students are going to get like, well, this is minus 4. Well, think of it this way. If you want to, this is really negative 4 times negative 6p plus 7. It's really that in disguise. Now, you just got to be very careful with this because a parenthesis kind of means times. So here we go. So we're going to go here and here. So here we go. What's a negative times a negative? A negative times a negative is a positive. So you should have positive 24 because 6 times 4, but what's included right there? It's that p. Okay, what's negative 4 times 7? So 7 times 4 is 28, correct? But negative times a positive is a negative, and that's 28. And some students, they're going to be like, well, is that all you can do? You can't simplify, you can't break this down. I say, no, that's pretty much it. That's it. That's all you can do. And sometimes students will kind of get upset because they're like, well, that doesn't seem right. That just seems like we didn't do anything. Yes, we did. We just multiplied this negative 4 and distribute into all that to make that. And another time as we go through the course, you're going to see that this comes in handy in order to make this work. Because we're going to start solving for that variable soon. But not right now. We have to build those skills. All right. So let's do number 4. And I want you to, let's try a little bit bigger one. Kind of make this be useful a little bit more. So 5 times p plus 1, close, minus 6 times 5p. So a little bit more challenging for you because you got to see some variety of these. Okay, so now what's what we're going to do here? Well, I hope that you recognize that we're going to do the distributive property twice. So we're going to just look and make a quick note here. We're going to distribute twice. Okay, that's distribute twice. Make it a little bit more clear for you. So we're going to distribute twice, and I hope that you can see that. If not, that's okay. So pretty much any time you see parentheses and you see a number outside is where you're going to distribute. So this 5 is going to go here. This 5 is going to go here. Okay. Now I don't want you to do this. I don't want you to take that 5 and go to here. No, that does not happen. This is pretty much it for that. So now you're going to go next part. You're going to go to here. Okay. So here we go. This is going to be 5p. It'll be 5p plus 5 minus 6 times 5 is 30p. You see how I'm keeping that negative in place? I'm not trying to make it do anything else. Okay, now do you see how we can actually put these two together? I hope that you understand that part there, that there's 5 of these and there's negative 30 of those. How can we combine those? Well, we have 5p here, we have negative 30. So you're going to say, well, what's 30 minus 5? And you're going to say, I hope 25p. You're going to say 25p. Because this, and there's more of these, there's more negatives of these. So that's going to be negative 30 plus 5. So you're going to have negative 25p. But what else are we missing? We're missing this 5. So this 5 is going to go right there. And that's your answer. Okay. Okay. So let's do some more. So this is number 5. Try this one. Let's do negative 1 times 5x plus 1. Let's make this a little bit more challenging. Divided by 5 times negative 1. So I hope that you can kind of see that this is that distributive property with a division. So this part means division. Okay, so we're going to have to divide. And then remember, you're also going to have to remember this guy right here, your PEMDAS. Okay, so here we go. What's negative 1 times 5 and negative 1 times positive 1? Well, negative 1 times 5x is going to be negative 5x. What's negative 1 times 1? Negative times a negative is a negative. 1 times 1 is 1. Okay, and then remember you still have that division symbol in there. And then what's 5 times negative 1? Well, you're going to say negative 5. Okay, well, in this part, we actually are done. You can actually leave this, and you'd be like, well, we're not using the PIMDOS, are we? Or that division symbol. And yes and no. We technically can go one more step, but I don't want us to make this complicated. So if you want to, this is just for this is just for extra. You don't need to write this down if you don't want to, but this is extra. Since this and this and this are a fraction, can't this be broken down into 5x over negative 5 minus 1 and negative 5? And yes, it can. So that's why I didn't really want to go into a step further, but just make sure you're paying attention to this. So sometimes you can't do the division at all. You're going to have to leave it for the answer. And that's going to be weird for some of you because you're like, I want to do something else. Don't try to invent new math. Okay, number 6. We're almost done here. Make a little bit more of a challenging one I thought about here. Let's do 3x plus 4 times 7x plus 1. Okay. So, a little bit more, it might not be that much of a challenge, but here we go. So, this 3x here is not going to do anything. There's nothing, there's no parentheses, so you're just going to go ahead and go 3x because it doesn't do anything. It just brings it down. Okay, the 4 times that and the 4 times that. So 4 times 7 is positive 28x. 4 times 1 is plus 4. And you see how I'm writing that plus 4 right there? It has to be very similar to this. It has to come out very similar to that. You see how this is a plus in there? There has to be a plus there. See, it's separated by that addition. So be very careful of that. Now, you can just say, well, I have 3 x's here, and I have 28 x's here. So how many altogether do you have of those two pieces? I have 3 of those x's and 28 of those x's. So I'm going to have 3 more. So that's going to be 31. So 31 x's plus that 4. And that's all you can do. So don't try to make it so what do you call it? So a little complicated that it's gonna not do well. Okay, so I have one more problem, and this problem is mostly about a little bit about shopping. You might like this one. So, for example, let's say that I have I bought 6 of something. So I bought 6 of something, and that was 12 of those minus 0.05%. So let's say I walked into the store and I bought 6 of something. The price was $12, and maybe I got with 5 cents. Maybe I had 5 cents, so I subtracted 5 cents. So let's think about this. Well, how are you able to do this? Well, you can do this now. So here we go. 6 times that, 6 times that. And you're gonna be like, well, I never dealt with decimals before. Yes, you have. So what's 6 times 12? 6 times 12 is 72. Okay, minus. What's 6 times, let's say this is 5 cents. How many 5 cents makes 6? So you're going to go 5 cents times 6. So what's 5 cents times 6? Is it 30 cents? Negative 30 cents. So negative 30 cents. Because 5 times 6 is 30 and cents. So you move the decimals still. Okay. Now, what's $72 minus 30 cents? What's $72 minus 30 cents? So $72 minus 30 cents. Make it easier like that. I know I'm not supposed to use that, but that's okay. So that's going to be $71.70. So there you go. Okay. I'm hoping that this is working for you. And that was 7 problems. I would hopefully you do go back through this and look at all these examples again and kind of see, you can kind of see a pattern here, ladies and you can almost see a pattern. And that's part of math, is that it's more pattern based. So don't forget the tricks. Make sure you're practicing this on your free time. And yes, please practice. Math is about practice. Okay, I will see you on the next video, guys.